All right, y'all. So here we go. Functions, operations, function operations, and compositions. Okay, so a lot of this, I'll go ahead and say, is a lot of notation. Okay, just bird's eye view. Function operations. There's four, right? And there's always kind of our four basic operations. You've got adding, subtracting, multiplying, and dividing. That's exactly what we're doing in the beginning. Okay, and then this next page is a little bit different, a little more complicated. That's what we call a composition on the back. But these first four, it is literally adding, subtracting, multiplying, and dividing functions. Okay, so let's just get that out of the way. In the beginning, it's just notation. Okay, so it's a little bit different if you might see the in parentheses f plus g first. But really, what you need to know here is that it is literally just you take f of x and you're going to add it to whatever g of x is. Okay, but that's just it's a different way to write it. You may see it like that for whatever reason. Honestly, the reason being I don't know why we write it like that, but it is literally just taking two functions and adding them together, combining like terms and adding them together. Okay, and then very similar with f minus g of x. It's you're taking f of x and then you subtract whatever g of x is. Okay, so that one's a little bit more complicated just because of that negative poses a little bit of an issue. But you take f of x and you subtract whatever g of x is. You combine like terms and you get a different function. Okay, when you see this, you might even see a like dot. Okay, just so you know. Okay, but notice this is don't get confused because this closed hole, right, is multiplication. Okay, but I'm just gonna quickly show you on the back. When it's open, that is a composition. Now we'll talk about compositions when we get there, but I do want to just note that this is a different symbol than multiplication. Okay, so I don't want you to get confused with that. When it's closed, when it's got the little closed hole, that's multiplication. Okay, so but f times g of x, what that is you take f of x and you're multiplying g of x. Okay, and with this, it might be, f of x times g of x. Okay, so you might see either of those. All right, but those are two separate ways of writing that. Okay, and then right here, f divided by g of x. Okay, that's going to be f of x, and we're going to divide whatever g of x is. So if that was the order, that's the way we would write it. Okay, and that's all those are. A lot of it, like these two, are just combining like terms essentially, and then these two you might have to like FOIL, or you might have to divide or factor, those kinds of things. But it just depends. Okay. All right, so this is kind of just a review of domain. I want to remind you that for the most part, when we're starting off, the only ones we want to look for on domain are if we have a rational function when something's on the bottom, we want to take, we can't divide by zero, so we want to take that out of the domain. And then when we have a square root, we also want to take, we can't have a negative within the square root. So we're going to take the parts that would make it negative out of the domain. Okay, but let's go ahead and look at each of these just real quick. No square root, okay, or rational here. So this is going to be, x such that x is all real numbers, okay, something like that. Okay, or you could do negative infinity to positive infinity if you wanted to do interval notation, but I just did step builder. It's just a little easier. Okay, g of x. Notice we've got a square root. Okay, so I need in the domain, I want everything that'll make it 0 or bigger. Okay, so my domain, x plus 3. Okay, my domain is everything that is going to make this greater or equal to 0. Okay, and that's my domain. Again, two different ways to think about it, right? You're in the parts that are in the domain, everything that will make this 0 or greater. You could also think about it as you're taking out the parts that'll make it negative. Okay, so that's kind of two different ways to think about that. But I'm going to go ahead and keep it like this. So we just solve from here. We subtract 3 on both sides. So x has to be greater or equal to negative 3, and that's my domain. Okay, and we could just write it into set builder notation. and that would give us our domain. Okay. Now, I mean, we always want to reason through these. Do not try to memorize. Okay.